Hi, I'm Dr. Dale Wagner, an exercise physiologist, and we're here in the lab today to do a body composition measurement, and we're going to be doing that measurement using bioelectrical impedance analysis, commonly just referred to as BIA. So BIA sends a low-level electrical current through the person's body. It's so low that the person can't feel it. It's a low voltage, low frequency. And with that electrical current, of course, a large portion of the body is water, so generally we're good conductors. And the water content in the body is found in the fat-free mass. So the fat mass is essentially anhydrous or free of water. And so the only thing that's impeding the current is the fat mass. And that's really what we're measuring when we do bioelectrical impedance. We're measuring the impedance or the resistance to the electrical current that's going through the person's body. So the first thing that we're going to do is we're just going to clean up some areas on our subject's skin so that we have a good conduction. And we're going to be placing 4 electrodes. So we'll have 2 electrodes on the wrist and hand and 2 electrodes on the ankle and foot. And we're going to be using the same side of the body for those electrodes. Traditionally, we measure things on the right side, even though I'm on the left here, that's fine. This is a relatively easy procedure. It's not difficult for the client or the examiner, so that's probably one of the benefits of this method. However, despite the fact that it's an easy procedure, you still have to be very precise on your landmarks in order to get an accurate reading. So I'm using some anatomical landmarks here, bisecting the styloid processes of the radius. And this one goes in down on the proximal phalanx of the middle finger. Down here I'm going to bisect the malleoli, and then we put this one down at the base of the toes. Also, the client positioning is very important. This method assumes that we're a series of cylinders, so 1 cylinder for each leg, 1 cylinder for each arm, and a cylinder for the trunk. So it's important to keep those cylinders separate, so you don't want to have the client having any body parts touching. She's in a good position right now. Also, we want to make sure that she's not wearing any metal because, of course, metal is a good conductor. And so you're not wearing any metal, right? Okay, and so that's it. Our setup is all ready. So we're just going to hook up the electrodes here. We have red and black leads, just like hooking up a battery on a car, basically. And our red lead is proximal, black lead is distal. And it's very simple. From here, I just turn on the device, and it's going to give me a resistance reading. And so this is measuring the resistance to the electrical current going through her body, and this number is in ohms. So right now she has 534 ohms. That number in and of itself, just by itself, doesn't mean anything, but we take that information and we put it into an equation. Other information that we would have to know for the equation would be her height. Her height is critically important because, as with any electrical current, the resistance of that current is dependent on the height and the cross-sectional area of the cylinder. And so in this case, the electrical current is going through her arm, down the side of her body, over to her leg. So we're really measuring the whole body, but half of the body, and then making a prediction based on that measurement. So certain advantages to this method: as you can see, it's simple to use, simple to set up, it's easy for both the technician and the client. It's also a good method for obese people. It's not, not dependent on body fat. The disadvantages to this method is it's very dependent on hydration state. Because of the electrical conductance and the fact that electrical conductance is based on the amount of hydration a person has, if a person is over dehydrated or if they're super hydrated, hyperhydrated, then that could be a problem with the readings. It could give us an errant reading.